here's a differential equation, draw the slope field, and then we'll do one where you have to figure it out from there, from the slope field. So they're telling you that at every point, the slope is x plus 1. So for example, you might make a table with, well, since you only have x, you can just choose the x value. So let's say when x is 0. So when x is 0, the slope dy dx is x plus 1. So that's obviously it's 1. So when x is 0, which is well, this is 0, 0. It's got a slope of 1 there. But here also, at this next point up, x is also 0, so it also has a slope of 1, slope of 1.
And there too, I see.
Yeah. Okay. Now when x is 1, your slope is 2.
2.
Yeah, so it's just a little steeper. You know, whatever a slope of 2 looks like to you. And then at 2, you get an even steeper slope of 3.
Right.
So however, you know, and this gets harder to do because we're just not that, you know, refined here.
Right.
How we do this, but you know, something like that. Now, when you're going the other way, -1, your slope is 0. So slope of 0 looks like that.
Right. Okay.
And then at -2 has a slope of -1. So if I'm an instructor, I'm looking for the ones that you can actually draw nicely, which is 0, -1, and 1.
Mm-hmm.
And at -3, you have a slope of -2. It's just a bit steeper.
Okay.
Like that.
Okay.
Okay, so it obviously gets harder when you have both variables involved. So let me grab one of those. So here you'd want to make more of like an ordered pair table for x and y, and then dy dx equals x plus y. But you're looking for points that I guess kind of like overlap or work nicely, which probably wouldn't be as obvious here, but like, let's say x and y are both 0. What is the slope?
0.
0. Okay. Now, what we're looking for is this right over. So like when x is 1 and y is -1, you also
how do you choose those points?
You're just kind of like looking at this equation and you're trying to find x plus y. You're looking at x plus y and you're trying to be like, well, where does something happen that's kind of interest? So at 1, -1 here, you also have a slope of 0. And so let's say I make x2, well, then y is -2. That also gives me a slope of 0. So
what if we did like 1 and 0?
We're going to do that, but what I'm trying to show you is that there's this pattern here of like all the points along here.
I see.
At -1, 1 and -2, 2, they all give you 0.
Okay.
And that kind of helps you to like, you're looking for a lot of places where you can do the same thing.
Gotcha.
So then another nice place is where it equals 1. Okay, and that happens at a number of places, right? Like 0, 1 or 1, 0. So these also are, oh, oops, I made those are completely wrong. At 0, 1, that's a slope of 1, slope of 1. Okay. So anywhere where these add up to 1, you're gonna have this nice slope. Okay, so like for example, -1, 2 is also gonna have that. So -1, so like here, and maybe you're seeing the pattern here of these things.
Yeah.
And that's kind of how you do them faster. You can do them point by point, but it's very slow because you want to be able to draw a few of these. So then the other one is where's the slope -1? So it's -1 when, you know, when y is or x, you know, whatever combination you get, like -1, 0.
So you're plugging -1. Wait, could it be like 0 and -1 though too, right?
That's right. So that one also works. It could be 1, -2. This one also works. This one also works. So you're looking for something like that that helps you to like draw them faster.
So you're looking for places where it's like 1, 0, where like the outcome is like 0, 1.
Yeah, 0, 1, -1, because those are easy to draw.
Okay.
And then the other ones, unfortunately, you just gotta like kind of fill in. Like at 1, 1, it's just the slope of 2. 1, 2.
So you just
Okay.
have to go through like each point.
Well, I mean, like hopefully you get one like this where you can do it fast, because it only depends on one variable. But when it depends on 2, yeah, you eventually.
So you have to go like 1, 2, 3,
Mhm.
3, 3. So you would have to do like,
Yep.
so that's 6.
Yeah, I mean, roughly, yeah. And then you do the same thing over here.
Right. Okay.
These are more negative, and I'm sorry, it's not like there's a nice way to do these.
I get it.
It's gotta pass the eye test. Like this, what I just did passes the eye test, even though these aren't all correct. I mean, they're in the right direction.
right.
So like you see them kind of going up. I mean, they have to pass that, or I mean, because your instructor isn't going to go in there and like look at every one. They're going to look at like, is there a general flow to this?
Yeah.
Okay. Do you want us to do another one?
Maybe one more.
Okay. I know this won't be that easy to do, but I was going to ask you to do as much of it as you could on your own. It only depends on why this time. So it's a good one for you to practice before I jumped in and work through it.
Make a little graph here. Let's see.
All right, I'd like to jump in here. What did you try to make the slope, or what y values did you try first?
Well, I did 0, 1, and 2.
Okay, so like so just as a suggestion here, whenever y is 0, which happens along this line right here, along the x-axis here, your slope is always 0. So like, I know it's hard to draw, but these are all horizontal lines.
Yeah.
Okay, and that's a good place to start there. Now, when y is 1, which happens all along here, your slope is
2.
always, so these have to have, some sort of increasing slope here. And then at 2, it's just even steeper.
4. Yeah.
Yeah. But on the other side here,
Wait, so it's more like upright at 4?
it's steeper. These should be steeper,
Oh, wait. Okay. Wait, I have that wrong.
because at 2, the slope is 4.
Wouldn't it be like more like less steep. I don't know how to say it, like.
So slope of 4 is up 4 over 1. That's a slope of 4. Slope of 2, you're just going up 2, right 1. It's the hypotenuse. I know it's really small, but
Oh, okay, I see.
hopefully, I mean, if I use the grid here, I start here, you know, up 2, right 1 looks like that. Up 4, right 1 looks like that.
Okay, gotcha.
If you've done any hiking, you know, you get a feel for what's steep and what's steeper, and that's kind of what you're looking for here. Now on the other side here, when y is -1, you get -2 slope down here, and when y is -2, you get -4 slope.
Right, okay. So just less steep. Or no, wait, steeper. Right, yeah, steep.
Okay, so let's let me do the following here. Let me grab a slope field and give you the options, and let's talk about a path to figuring it out here.
Okay.
Actually, let me see if equation that's okay. So to be fair here, this is not quite right. These should all be dy dx over
Okay.
here. So this is saying no. Maybe. Sorry, give me a moment here to try to figure out what's going on here. Yeah, this is not right. Okay, I'm sorry. These are not, this is not the right problem. Let's look at, they're giving you the solution of the derivative of the differential equation, which is not what you want. But I found there's some other ones here, so we can do that first. So let's do this one. 13. Okay, so there's your slope field. And then here are the possible equations that it could come from. And this is, I think this is a reasonable difficulty for what you're trying to do. So you said it might be something like this. So notice, like, you want to look for like nice points. So see how at, I don't know, 0, 1, that has a slope of 0.
Yes.
Okay, so there's a few of these that could work, right? But the same thing has to happen at 0, 2 and at 0, 3. These all lead to a slope of 0. So like number 1 could be it.
How do you know that they all have to? I don't.
I'm just gonna let me do it in a different color here. I'm looking at these points right here.
Oh, I see. Okay.
And they all have a slope of 0.
Okay.
So like I know that this is out because the slope there is the y value.
Yeah.
And the y value is changing here, so it can't be that one. Do any of these other?
D.
I'm sorry.
D.
That
one works.
That one works, but so does A. No, I'm sorry.
Oh,
I'm sorry. I'm sorry.
A would have the adding one. Yeah.
A does not work. I'm sorry, but D does. Okay. So that is one way to do this, where you kind of look for nice,
Nice
features. So let's continue. And let me snip in. Let me grab the answers here again. Answer space. Okay, so again, like I would kind of look for nice points, like either, you know, something along here. Or maybe something along here, although sometimes it's hard to tell if that's 1 or the one to the right of it's 1. These horizontals are usually pretty solid. So that's at like -3, 0. That's at like, -3, 1. No, I'm sorry, 2.
1, 2.
Wow, sorry, I'm not counting. -2, -2, 2. So all of these give you 0.
So you plug in.
So sometimes it's like, can you eliminate any of them?
1, you would have to get. So you're plugging in the X value into this?
And the Y, if you think B is right, which it could be, then
Right,
then
so
B is, you have to plug them both in.
that one would be -2 minus 0. So that gives you -2.
Right.
So no, wait. -2. Oh wait, that one could work. So then.
But it's got to work at all the points.
Yeah, that's
there.
what I'm checking.
So like, does the next one
So
actually
then
give you?
-2 minus 1 equals -1, which is -2, 1. No, that one doesn't work.
Yeah, so this one's probably out.
So then Y, let's see. So if you just plug in 0, that gives you -2. No, that one doesn't work.
So I'm kind of drawn to A, but for a different reason. It's for this one right here. So here, along here, X is 0. And so when you put 0 in there, you get,
you get like
you always get
1.
Yeah, it doesn't matter where you are. Okay, so that's why you got to be careful, to do that. Now, another thing that you can do, and this is a little bit more of an advanced way of doing this, you would see this in your differential equations class, and maybe your instructor said this, is sometimes you try to trace like the solution. And you say, oh, those look like quadratics. Right? Do you agree with that? Those kind of look like quadratics.
Yeah.
So which of these, this is where it's a little more advanced, which of these produces a quadratic when you're all done?
Oh,
and the answer is A, but that's, there's a little bit more to that.
Yeah, I don't really remember what quadratics look like.
Okay. So for, for what it's worth, that's a technique here. Now, let's look at another one here. Hopefully these are harder than what you will see. So at least one of these strategies will work on your test. Okay, so like you look for a place on the graph that's doing something kind of consistent or interesting, and
so that one, yeah,
these,
and the one next to it, the one to the right, yeah.
So and then you pick one, and hopefully one of them matches up here.
If you choose like 0, like 0, 0, 0, and no, wait, no.
So
1 and 2, no, 1 and 1.
So 0, 0, 1, 1, 2, 2. Whenever x equals y, and that's what this means right here. Whenever x equals y, the slope is always 1, or I'm sorry, the slope is always 0.
Yeah. So
it's got to depend on both x and y is kind of the short of it.
And so it has to be 0 minus 0, that's 0, 1 minus, so it's B.
It's B. Yeah. And maybe by process elimination, we used D already, so you would, but if you only had one choice, you'd also have to realize that you can't divide by 0. So something weird would have to happen when y is 0. Also.
Right. Okay.
Okay, so the last one here, been and again, by process of elimination, we kind of already have the answer, but
Oh, I didn't even know this was like the same.
oh, sorry. Yeah, it's hard to come up with new ones each time.
Fine, I don't remember other than the one we just did.
Yeah.
So, oh god, this one's harder.
Yeah, like it's not clear what's going on along the x-axis.
Well, it's like a flat line.
So like what I see is in this upper region, it's going up, and in this lower region, obviously it's going down.
Yeah, but like, okay, so
how does that help, right? Well,
yeah.
so if you were to try drawing some curves here, like, and it's probably not that obvious, but like one of the solutions look like that, another solution looks like that when you graph the solutions. And you may or may not remember that these are e's. So let's solve this. Let's just kind of continue now from where we left off yesterday, which is like, let's just solve one of these differential equations using separable differential equations, so you can see that. So if you recall, you're going to divide both sides by y, and then this dx just comes over here. So on the right, it's just 1 dx, but on the left, it's the integral of dy over y.
And so then you have to do the antiderivative.
That's right. That's right.
And then you move over the x.
Well, you use e here because you want to solve for y.
Oh, right. So e to the ln y.
Yes. So y equals e to the x plus c.
So
and then a lot of students do here, a lot of instructors want you to do is they want you to rewrite it like this.
This c is the e to the the c being raised to the e to the x too?
Yes. Yes.
Oh, okay.
Yes. And then you're using this property here that x to the n times x to the m equals x to the n plus m.
Right. Okay.
Okay. So now bring your c out in front. So you say e to the c equals c. So y equals c e to the x.
Y equals, okay.
So now, why did I do all that? Because that's one of the techniques here, is if you can see the solutions, which, I mean, you got to have some comfort level with that. But if you realize, oh, that's e to the x, that came from this differential equation, you could actually solve each of these differential equations to get their slope. It's like, I don't think you're supposed to do that, but that is kind of an approach here. Now, if you go back to seeing how the red like increases and decreases, that's because it only depends on y. Like as y gets bigger, the slope gets bigger.
Oh, okay. Okay, I kind of understand that.
All right, let's do another one of these separable differential equations. This next one here, dy dx equals minus x over y. I'd like you to try solving this one.
So you just do, so it's dy over y.
Well, remember, you're this time you're multiplying by y, because it's you're just trying to undo it to get to the other side.
Oh, so you wait, so multiply by y. Oh, so y dy equals, and then you're multiplying by 1 over dx, right?
Yeah, or just by dx. I'm sorry, you just multiply by dx. Like if that's how you're seeing it in the class, that's fine.
Okay, so x dx or negative x dx. Okay, and then do integral dy equals integral negative x dx. So that's y squared over 2 negative x squared over 2 c, and then oh wait, so you're trying to get y by itself, right?
Well, let me give you an initial value here.
Oh,
for this one. Let's say 4, 4.
Okay, so 4 squared over 2, negative 4 squared over 2, let's see. So it's 16 over 2, so 8. 16 over 2, 8. So C equals 0.
You're adding 8 to both sides. Because you
That's-
square before you negate.
Oh, that's what it is. Okay. Oh, 16. Oh, that's so okay. And then it's y. So you put it back into the
Yeah, you put it back into the
antiderivative. Y squared over 2 equals negative x squared over 2 plus 16.
So notice like if you multiply everything by 2, you get y squared equals minus x squared plus 16. And then you move the x squared over, you get x squared plus y squared, I'm sorry, 32 equals 32. And from your previous classes, you actually would know that this is a circle.
Oh,
And if you notice, the slope field that it came from is a circle. That's not completely there, but
nice. If you, okay, so like when they're asking you for the final answer, would you leave it as like the y squared over 2, or should you like make it?
I don't know. That's a real preference. I don't know. You got to ask your instructor what they want. Like, I feel like this line is correct, this line is correct, and this line is correct. But
couldn't you do like the square root also?
you could, yeah. You could say y equals plus or minus square root. I don't know.
Okay.
I wish I gave you a better answer than that, but I really
Check what he put on the slideshow today. No, those are different. Okay, never mind.
these are topics that, like, in the workplace, it's like, how should we present the final whatever product we have, whether it's this or a memo, or these are arguments that go on how to name files. It depends on who's in charge. That's the answer.
Great.
Right. I think it'd be good to transition to the review exercises and maybe look at, I don't know which problems you need done, but we could
They're
do
on
some.
the end of the
Okay.
that slideshow I sent. So it's like 2, 4, 12.
Yeah, let me see if you're doing 40 or you're doing 40 and 42. Those are slope fields. So I guess let's take a look at those together since they're related.
Yeah.
So the quality of these, I guess it's okay. All right, so now our questions, we're doing 40 and 42. Okay, so we're gonna look at 40 first. Let me actually snip this differently so we can just snipping this in. All right, so when we're looking at question 40, there's a denominator down here.
Yeah.
And you have to like almost like set this equal to 0 and say, oh, when x equals y, something really bad happens because it's a denominator. When x equals y, you end up getting division by 0.
Like, you mean like, so if it's like 1 minus 1?
Or no, well, x equals y, so like 1, 1, 0, 0.
Well, yeah, so that would be like 1 minus 1 would equal 0.
Yeah, exactly. Yeah.
Okay.
And this is like, you're trying to find something like this to help you. So when you divide by 0, do you remember what kind of slope that is?
Isn't it like an undefined?
Yes. So it's a vertical line.
Oh.
And that's
okay.
what you're looking for here. So you can actually sketch the line x equals y. So I'll do that in blue. And and what you're looking for is at kind of at those points. Oh, this isn't a square window, is it? No, it's not. So your square window, so along that line there that I'm drawing roughly, the slopes should all be horizontal. I'm sorry, vertical.
Wait, what's a square window?
Well, it has more in the left than the right. If you look, yeah. So see how D, and that it's kind of hard to see, but D has these vertical slopes. I guess it's there. See how they're kind of even hard to see.
Yeah.
You gotta, yeah.
That one, yeah.
I don't know. It's really, I guess it's that one. It's hard to see. Okay, so this is obviously D now because of that. If you didn't know that, you would maybe never figure this one out because you would make a table and you'd have to guess, kind of correctly.
Right.
Okay, so let's look at 42 now. So we know it's not D,
Those
but
are hard to see. There's like so many
yeah.
things going on.
Yes. So now when I look at the numerator of this, okay, when X equals 0
Or
Y equals 0, which means along the axes, something interesting happens, which is that the slopes are always 0. So that one is looking pretty good, but so is that one.
Right.
So that's not enough. Now we can do some other things here now. Like you can look at signs. So like, what do you know about the first quadrant? In quadrant 1,
They're both
X,
positive.
yeah. So that tells you, because you're negating it, that you should have a negative slope in that quadrant.
But for what? For like,
well, pick any combination of numbers should give you a negative slope in the first quadrant.
oh, I see. Okay. Tricky. All right.
Yes. So a little bit of elimination, a little bit of like actually doing the problem to come up with the right answer. So that's 40 and 42. Let's see if 52 is, no, 52 is something else. Are 37 and 38 part of your
38 is
38? Okay, let's look at that one together. So this one's a sketching exercise. It fits in nicely with what we've been doing. So there is your grid, and then 38 is the differential equation. And it's like if I'm an instructor and I'm giving you this, I may be changing it to like 1 plus y or making it like an x. I know there's a lot of variation on there, but it's not going to be something really all that complicated here. But when we've done a couple of these and you're looking for something like, usually you want to figure out when does this thing equal 0, and it equals 0 and y equals 1.
yeah.
So when y is 1, the slope is 1 minus 1, which is 0. That means,
So anywhere along the, yeah.
okay, well, that's great. But we always have to fill in the rest of this. So another good point is when
Yeah.
Y is 0. So when y is 0,
It's 1.
yeah, when y is 0, the slope is 1. So those are here.
So those are like closer to, what is that? So that's like less steep. Yes.
Well, it's kind of that 45-degree angle is y equals 1, or a slope equal to 1. That's your 45-degree angle. It's still, that's actually pretty steep. Like you actually never hike anything that steep in Tucson.
Well, like slope of 2 is even more steep though, right?
That's correct. Yeah,
okay.
That's correct. So when y is -1, the slope is always 2. So the lines under here, you just have to show them steeper. It's like relative, not necessarily.
And then 2, it's 1 minus 2, so -1. So it's
Yes.
the other way, like
It's down 1 over 1, down
right.
1 over 1, down 1 over 1. Yeah.
Okay.
So if you can do all that, you got it. I mean, you're in great shape.
Those are weird.
Work them again. I think you'll get them.
Okay.
So we got some other problems here. I can start at 2. We can look at maybe something else from the notes.
Oh, I think we want to go over what's it called? The
Newton's law of cooling.
Yeah, he said he would give us the like equation on the test. Like we just have to like know how to use it, obviously.
Okay.
But the last slide, 12, has a example.
Okay. Yeah, let's go through the example. The sort of the summary of Newton's law of cooling is you need 2 data points to determine the time of death, and that's how it's most often used. So if you've ever watched like crime shows where they take one measurement, that's not enough. Or if of course, if you've seen where evidence has been tampered with because the body or something has been put in the cold or the heat, then you don't get these 2 data points. So that's why it's so important to do. So having said all that, it also applies to things like turkeys, in the oven, and like it's not just cooling, it is heating also.
Okay.
So are you saying you're going to get this
Yeah,
equation?
he said he's gonna give it to us.
Okay. That's great. I mean, you're literally just solving for the unknowns here.
Right.
So we got to go through like what some of these actually are. Usually it's big T is a function of little t equals TS, which I guess is surrounding. Is that how you remember it from class?
What do you mean?
The
The S?
Yeah, is that what it's the
I don't
derivative for?
remember.
Usually that's what it is, and sometimes it's A for ambient, or the temperature around you. So let me see if I can figure out what the instructor's doing here.
He says surrounding temperature is TS.
Yes. Okay, so it says an aluminum beam was brought in from the outside cold into a machine shop where the temperature is held at 65 degrees. So 65 degrees is your TS, because that's the temperature, like everything will eventually warm up to that temperature. You ever had a cup of coffee? It cools down to whatever the temperature is outside. And
But that's things. Like you're starting?
Not necessarily, like, because it's cold. Like imagine you go to your freezer and you pull some out, it's cold, and then you set it on the counter. Eventually it will reach the temperature that the whole house is at.
Right.
And that's what TS is. TS is the I like ambient. It's the what it'll eventually get to.
Gotcha. Okay.
Okay, so we can I guess just substitute this value in.
Okay.
So T of T equals 65 plus.
Wait, did you just write that equation a different way?
I did. I moved because what's not clear in this, what your instructor gave you, is that like this is your output and your input is there. It's only a function of time. All these other things are constants.
Gotcha. Okay.
And I moved the TS over and left it in this form.
Okay.
Okay. So now E to the minus KT. Okay, so we're still not in great shape. We got 2 unknowns. Okay. So it says after 10 minutes, the beam warmed to 35 degrees Fahrenheit. Sorry, you can't see that up here. And then after another 10 minutes, its temperature was 50 degrees Fahrenheit. So in this problem, they're using minutes. Okay, you may or may not be using minutes, and they may mix. They might give you like in the classic problems they get it in this differential equations class. They give you time of death, 8:03 a.m. and then 8:15 a.m. But you just keep your units consistent is the point here. So 10, 65, and then another 10 minutes, 20. Sorry, this is the wrong time. It's 50, or the wrong temperature. It's 50. And then 20, it's Wow, that's really bad. It's 35, not 50. So it's getting warmer. It was 35 degrees, now it's 50 degrees. So this is little t, and then this is big T. And that's also another confusing thing when you're doing this for the first time is the mixture of the upper and lowercase variables. So the first data point is 35 equals 65 plus T0 minus 65 e to the minus k times 10. Is that okay? Uh-oh.
Sorry, I don't know if that was me or.
I heard a sound like you, your computer shut up. Are you still seeing my screen now?
Yeah.
Okay. All right. So all I did, and I think this is where we left off, is I just substituted this first data point into the equation here.
Okay.
And then I'm going to do it again for the second equation. So the second one is it's 50 equals 65 plus T0 minus 65 e to the minus k times 20.
So if you did it the way that he has it, would it be like it would be 35 minus 65 or 65 minus 35?
Yeah, and that's why I left room here. We actually do need to do that. So we're going to subtract 65 from both sides. So you get equation one is minus 30 equals T0 minus 65 e to the minus 10k. And then you're going to do the same thing in this line. You're going to subtract 65, subtract 65. You get minus 15 equals T0 minus 65 e to the minus 20k.
Okay.
So now what I'm going to do is I'm going to bring this other equation down, and it doesn't matter whether it's top or bottom. It really doesn't. You can either put on the bottom or top, doesn't matter. We'll do it like this. And then this is kind of a cheat here, but you divide. You're really substituting, but this always works. That's why you just divide here. So when you divide minus 50, yeah, you get a half, which doesn't always work out. Like that just happened to be the case here. You might get a fourth, a third, a tenth, 2/5, who knows? But on the right, what you're supposed to, these cancel. And then because you have the same base,
subtract, right?
You subtract. So it's minus 20k minus 10k.
So plus, wait, 20, wouldn't it be plus 10?
Plus 10k, yes.
10.
Yes, and now you solve for k.
So you do ln.
ln of both sides.
And then you get an ln of 1/2 equals negative 10k.
Yes.
So then 1/2.
You definitely need a calculator for this. You're going to be given this one, unless the instructor says they wants it symbolically, because you could take this and substitute it back in to find the initial temperature. But
if you move negative 10 up as a fraction, wouldn't it get rid of the negative? Isn't it ln 1/2 over negative 10?
Yeah, and that's the same. So it's yeah, I mean, this is also correct.
Okay.
It's exactly the same. So actually the way your instructor does it is your instructor says, no, we can actually use this. Okay, because we want to solve for T0. Okay, so T0 is, we got to use one equation or another. It doesn't really matter. I'm going to choose this one, I think. Just go grab that.
Does it matter?
No, but this one looks slightly better because there was a minus 10 here that will cancel with that. So just slightly better, like not. So you have to take this and substitute this and substitute in for k. So you have minus 30 equals T0 minus 65 e to the minus 10 times natural log of 1/2 over negative 10.
Oh my goodness.
Looks bad, but it works out, actually works out okay. These negative tens cancel.
Yeah. And then it's 1/2 because the e's and the
That's right.
ln.
So it just becomes 1/2. So you're down to, an equation that you could solve when you're in pre-algebra or algebra 1, because there's only one variable. Now
You multiply by 2.
multiply by 2 minus 60 equals t0
And then you
minus,
add 65.
yes, you add 65 to both sides.
So that's the
Yes. So there,
initial.
yes, there's a, a beam here. It was 5 degrees, and then you went into a room, a house or something, and the temperature in the house was 65 degrees. So eventually this thing warms up to that temperature when it's inside the home.
Okay. Right.
So I would definitely like practice these steps a few times.
So
like,
it's you can like I can start it the way that like where it's just t minus the ts that way. Like it doesn't matter.
yes, 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 yes. So we don't have enough time to do 52, but we can at least like set it up and see how far we get
Okay.
with it, because it's the same thing. Okay, a pie whose internal temperature is 220 degrees Fahrenheit was removed from the oven, was set out on a 40-degree F breezy porch. So your TS is 40 degrees.
Okay.
Your T0, and that's different, is 220 because that's what you started with.
Okay.
And then you have to infer that from it. Now, they give you one data point this time. They tell you that 15 minutes later, it was 180 degrees. 15 minutes later, excuse me, 180 degrees. So now let's go back and grab that equation.
What's the 70 for?
That's like, remember we talked about some problems yesterday where you always find the constants. Well, now once you find the equation, you then solve it for 70.
Oh, okay.
Okay, so we're just going to substitute in what we have here. So it's t minus 40 equals 220 minus 40 e to the minus kt.
Okay.
So t minus 40 equals 180 e to the minus kt. And then you're going to use this data point, where that's t and that's big T, to solve for k. So you get 180 minus 40 equals 180 e to the minus k times 15.
And then once you get the k, you
would substitute it back in. So k in this case is going to equal 140 over 180, natural log of that, over minus 15. You take that and put it back into this line right here, and then you set t equal to 70. And we can for sure do that next time if we need to, but that's enough to solve this. So
great.
Okay, well, that takes us to the end of our lesson today, and I will see you, I guess, a couple days. Thanks so much for scheduling, and I'll send you the notes here shortly.
Thank you.
Great day. Bye now.
Bye.